Now I want to use what we know about finding surface area to confirm that the surface area of a sphere of radius rho is 4 pi r squared. And to start off with, I've got just the formula of a sphere of radius rho here. X squared plus y squared plus z squared equals rho squared. And then I used what I knew about spherical coordinates to write a parameterization of that sphere. And the parameters here are theta and phi, and they mean what they were as defined when we studied spherical coordinates. Now, also, this formula, or this integral, this double integral, remember, is how we calculate surface area for a surface that's been defined parametrically. So what I need to do, in my case, I don't have u and v, I have theta and phi. So what I need to do is find those partials. So that's the first order of business. So I want to find the partial with respect to theta. And I'll do that first of all. And of course, I look back at my original, and the partial with respect to theta, this first one is just going to be negative rho sine phi sine theta. Okay, so the cosine theta, that was what I had to differentiate, and it's negative sine. The next one, I have rho sine phi, and this time cosine theta, because I differentiated the sine part. And then finally on the end, it's just 0, because there's no theta in that term. So it's just a constant, and it's 0. Now let's look at the derivative with respect to phi. So now I'm going to differentiate the first term with respect to phi, and I'm going to get rho cosine phi cosine theta. And the next one, same thing, rho cosine phi sine theta. And then on the end, I have negative rho sine phi. So now we're ready to calculate our cross product. And I'm going to do that and then take the magnitude of it before I try to talk about the integral. So now, to do this cross product, here's what I've got. And I want to be sure and give myself as much room as possible here. So I've got r theta cross r of phi. So let's see what that's going to be. I've got I, j, and k. So here we go. First thing, I've got negative rho sine phi sine theta. Here's rho sine phi cosine theta, and 0. And then down here, the next one, rho cosine phi cosine theta, rho cosine phi sine theta, and then finally negative rho sine phi. Okay, so now I'm ready to go ahead and compute that cross product. So taking out the first column, it looks like what we have is negative rho squared sine squared phi cosine theta. And that's it. That's it for that term. Now we take out the middle term, and it looks like we've got negative. I just start off with a negative there. I multiply, and I get rho squared sine squared phi sine theta. And that's it. And we get that negative from the fact that that middle term starts off with a negative. We just take the opposite of whatever that product is. Then for the last term, the z part, I take out the z, and I get this. I get rho squared sine phi cosine phi and then cosine squared theta. Minus, which is going to make a plus. So I do this minus this, and then I get rho squared sine phi and then sine squared theta. Well, I forgot the first term. I forgot one of the parts to this, the cosine, right? So the cosine phi. And then the sine squared theta. Okay, so this is the cross product. Now what I've got to do is compute the magnitude. And the magnitude, so here we go now. So this is going to take up quite a bit of room. So we have theta cross the cross product, the magnitude of that. So I'm going to start on a new line. And I'll go down here. So here we go. I'm going to square the first term. So this is going to be rho to the fourth sine squared phi. Actually, it's sine to the fourth phi. Cosine squared theta. Okay, so that's that first term squared. Now the second, now I go to the next one, and this is going to be rho to the fourth sine to the fourth phi sine squared theta. Okay, so that takes care of those, and those are pretty simple because they just had one term. Now, for this next one, I'm going to need to do a little bit more. In other words, I'm going to have to, this is like two parts that I'm going to square. So this is going to be a little bit more work. Now, just notice the mistake that I made when I was getting this last term. This should be a negative here and a negative here. Just notice that. Because I was getting ready to multiply out. Because notice for that term, we're taking this product, which we've got a negative, and we're minusing. Okay, so we're minusing this. So both of those terms are negative. Okay, but now we're ready to go ahead and multiply it out. So here we go. I'm going to square the first term, which is going to be rho to the fourth sine to the fourth phi cosine, well, sine squared phi. Sine squared phi, cosine squared phi, and then cosine to the fourth theta. Now the next thing we do 2 times the product. So this is going to be 2 phi to the fourth sine squared phi cosine squared phi, and then cosine squared theta sine squared theta. So that's 2 times the product, and then the last term squared. So that's going to be rho to the fourth sine squared phi cosine squared phi and sine to the fourth theta. And it looks like we got that all in on one line. Hopefully I didn't mess up any more than I already have. I think I fixed everything. Okay, now our job is to simplify this. And probably where we want to start is we want to see if we can factor out anything and utilize the Pythagorean theorem to make some of these terms disappear, or go to 1 anyway. So if you look at the very first part of this, notice that there's a rho to the fourth in every one of these terms. So let me do this. Let me factor out the rho to the fourth, take the square root of that, and I'll just get rho squared. That's what's going to be on the outside. Now I can do that. I can just take it's no problem because it's in every one of these. And I know definitely rho is positive. Now, here's what I want to do. I notice also, like for this first set of terms, I've got sine to the fourth phi. I can factor that out and I get cosine squared theta plus sine squared theta. Now, that came from these terms right here. See, I just factored out sine to the fourth. And I like doing that because I know sine squared theta plus cosine squared theta is 1. Now, we come along here, and I look at this next term, or let's see what we can do now. I've already factored out the rho to the fourth. Now, I think what I can do is factor out a sine squared phi, cosine squared phi. So let's see what that's going to look like. So if I factor out a sine squared phi, cosine squared phi, let's see what I have left. I have cosine to the fourth theta, because I factored these out, plus 2 cosine squared theta sine squared theta. Okay, so that's this right here. And then plus sine to the fourth theta. Okay, so there's what I have so far. Okay, so let's continue. Here's what we've got now. We've got rho squared, and this is just sine to the fourth phi. Now let's see what else we can do. And then we've got plus sine squared phi, cosine squared phi. And this thing right here, looks like I can write that as cosine squared theta plus sine squared theta squared. That looks like what that is, so that's just 1. So let's see what we've got now. We've got rho squared, and now I've got sine to the fourth phi plus sine squared phi, cosine squared phi. Okay, so there's what we have so far. And then, of course, 1 squared, it's just gone. Okay, now let's see what else we can do here. So now we've got this one. We've got rho squared, square root. Let me factor out a sine squared phi. And then we've got this. We've got sine squared phi plus cosine squared phi. Okay, so I factor the sine squared out of here and here, and there's what I have. Now it looks like I just have rho squared sine squared phi. Because sine squared phi plus cosine squared phi is just 1. Now, we're dealing with sine, we're dealing with a phi between 0 and pi. Sine is positive in that interval, so I can just immediately write this as rho squared sine phi. Now, that's what I want to integrate. So now I'm ready to set up my integral. My integral is going to go like this. It's a double integral. I've got rho squared sine phi. And I want to integrate, I guess I'll do phi first. So, and remember rho, we're just saying that is the radius. So we're not going to integrate with respect to rho. So I've got d phi. And phi goes from 0 to pi. And then theta is going to go from 0 to 2 pi. So now let's see what we have here. From 0 to 2 pi, and then the antiderivative sign is negative cosine. So rho squared cosine phi from 0 to pi d theta. Okay. Now we keep going with this, and I get 0 to 2 pi. If I plug in a pi into cosine, I get negative 1 minus, and I tell you what, let me let me factor out the rho real quick here. Let me factor out the rho. I'll just put the rho squared out here. Now, if I put in the pi into cosine, so here's what I've got. I've got cosine of pi minus cosine of 0. Okay? And I have to remember I have the negative in front of the cosine. Probably should have factored out the negative from the beginning, but that's okay. So now we have rho squared, and now we have 0 to 2 pi. Cosine of pi is -1 with the negative in front. That's just 1. Cosine of 0 is 1. So this is 1 plus 1 d theta. So now we have this rho squared 2 d theta from 0 to 2 pi. And now we've got a very easy integral. The antiderivative of 2 is 2 theta. So here we go. This is 2 theta, and there's a rho squared in front from 0 to 2 pi. So that is going to be rho squared 2 times 2 pi, which is 4 pi rho squared. And that is the formula for the surface, or that is the surface area for a sphere of radius rho. So that's what we were able to show.